In today's lecture, we are going to learn how to draw the shapes of the 5d orbitals. D orbital is quite difficult to draw if you don't know the following logic I will use. Now, the shape is rosette shape or double dumbbell, right? And we have 5d orbitals, which I'm going to write out now. But before I do that, please click on like, share this video, and subscribe to our YouTube channel. Number 1 is dxy orbital, and number 2 is dxz orbital. Number 3 is dyz orbital. Number 4 is dx square by y square orbital. And number 5 is dz square orbital. Okay, let us start from number 1. But before we start drawing the shape of orbitals, we know we have to represent the 3 axes of the space. We first represent the 3 axes of the space. This is plus x-axis, this is minus x-axis, this is plus y-axis, and we have minus y-axis, plus z, minus z. Again, let me remind you that the shape of d orbital is double dumbbell. That is, this is a dumbbell shape, right? The shape of p orbital. Then, for d orbital, it is double, like this. So, there is a question of how to place this on the 3 axes of the space. Now, we are going to do it one by one. We will place the first dumbbell, then place the second dumbbell, using the following logic. To draw dxy orbital, remember we have x, y, z, and there is no z here, right? For that reason, the first dumbbell is going on z-axis. Yes. The second dumbbell is going in between what you are seeing here, x and y-axis. This is x-axis, this is y-axis. So in between them, you put the second dumbbell. Number 2 is dxz. So I draw the space x, y, z. It's not necessary to put the negative values of the axis. We are going to follow the formal logic. X, Z. Y is not here. So the first one goes on Y. And then the second one is going in between X and Z, right? So this is X and this is Z. Here is the in between. So we place it there. That is dxz. You can see the two are quite different. They have different orientations, but the same shape. Number 3, that is dyz orbital. We draw the space. The same logic goes yz. There is no x. So the first dumbbell is going on x, and the second dumbbell is going in between y and z. Dx squared by y squared. Now, from this number 4, we are going to change logic. The logic is this. Since both x and y are squared, you put the both dumbbell shapes on x and y axis because they are squared. So one goes on x and the second one goes on y. Okay, number 5. This particular orbital actually has a different logic because it does not contain 2 letters. It only has 1 letter, z. Now, we are going to borrow a logic from here that says that once a letter is squared, you put the dumbbell on the axis of that letter. Here, z is squared. We are going to put the dumbbell on z. We put a dumbbell shape on z axis. Now, there is a question of how to put the second dumbbell shape. There is no x there, and there is no y there. In the previous logic, where there is no alphabet, we place the dumbbell on that alphabet. Like there is no z here, we placed on z. There's no y here, we placed on y. There's no x here, we placed on x. Here, there's no x and there is no y at the same time. And it's only one dumbbell that we want to draw. Are we going to place it on x or y or both of them? Naturally, you expect the dumbbell shape to exist at both axes, x and y, at the same time. And that is the only thing that will resolve it. How will it happen? The dumbbell trying to be on x and y at the same time will distort the shape of the dumbbell. The dumbbell will acquire a shape like this, so that it will touch both x and y axis. Remember, z axis is like this, x axis is like this, and y-axis is like this. So for this second dumbbell to be on both y and x, it means it will go around z so that it will touch y and also touch x like this. It goes round like this. You see, it touches y, x, but it does not touch z. Z passes in between. If you are an exam candidate, subscribe and follow us on all our social media handles. And if you have a friend who is an exam candidate, refer that friend to this channel.